You ever notice that? How some things feel instantly cold when you touch them, while others can suddenly feel warm? It's not magic. It's actually just physics. So let's dive into this invisible world of thermal energy that's happening literally right in the palm of your hand. All right, we're going to start with a feeling that is super common, but the science behind it, it's surprisingly cool. And yeah, sometimes surprisingly hot. It's this little mystery we encounter every day. Just think about it for a second. The moment you squirt some hand sanitizer on your hands and rub it in, bam, you get that immediate chilly feeling. The bottle wasn't in the fridge, right? So what's going on there? Okay, now let's flip the script. For the total opposite effect, let's look at another common household thing. If you've ever saved mixed washing powder with a little bit of water in your hand, you might have noticed it actually starts to feel warm. So there you have it. Two really simple actions: putting on a liquid, dissolving a powder. And yet, they create completely opposite feelings of heat and cold. This isn't just some random quirk, you know? It's a fundamental principle of chemistry and physics at work. And we are about to solve this thing. So to really get our heads around this puzzle, we need to get to the heart of it all, which is all about how energy behaves when stuff changes. I mean, think about it. Every physical process, from ice melting to water boiling, involves a transfer of heat. That's it. Energy is either getting sucked in from the surroundings, which makes them colder, or it's getting pushed out into them, making them warmer. And that simple exchange, well, that's the key to this whole mystery. Yeah, just take a look at this. To move up the chain, so to speak, like from a solid ice to a liquid, or from a liquid to a gas, the substance has to absorb heat from everything around it. But to go the other way, like when water freezes into ice, all that energy has to be let go. It has to be released. Okay, so we've established that heat is always on the move. But the big question is, which direction is it going? Is something giving heat away, or is it taking heat in? That distinction, it's everything. All right, let's bring this back to our examples and see how this all connects. The act of dissolving something, or, evaporation, it's a physical process, just like melting or freezing. And what that means is it has to involve a transfer of heat energy. So the question remains, which way is it flowing? So scientists have a couple of fancy but actually pretty simple words for this. A process that absorbs heat from its surroundings, that's called endothermic. Endo kind of means in. And a process that releases heat into its surroundings, that's exothermic. Exo means out. See? Simple as that. Heat goes in or heat goes out. So when an endothermic process happens, it's basically stealing heat from whatever it's touching. It's a little heat thief. If that something it's touching is your hand, well, your hand is losing heat, and your brain just interprets that loss of heat as feeling cold. And then, on the flip side, you've got an exothermic process. This one is generous. It's giving away heat. It's releasing energy into its surroundings. So when that happens in your hand, your skin soaks up that released heat, and you feel warm. Okay, now that we're armed with our new vocabulary, endothermic and exothermic, let's go back to that original puzzle and crack this case once and for all. And there it is, all laid out for us. On the left, we've got the hand sanitizer. Its evaporation is an endothermic process. And on the right, the washing powder. Its dissolving is an exothermic process. See, we've just put a name to what we're feeling. Let's just walk through it one more time. The alcohol in hand sanitizer, it evaporates almost instantly. And to do that, to go from a liquid to a gas, it needs a quick burst of energy. And where does it get it? It yanks that heat energy right out of your skin. So your skin loses heat, and boom, you feel cold. Meanwhile, as that washing powder dissolves, the way its molecules mix with the water actually releases energy, which heats up the whole concoction right there in your hand. Now, this is way more than just a neat party trick or a fun little observation. These fundamental principles, they're actually harnessed to create some incredibly useful everyday technology. Because when you understand whether a process is endothermic or exothermic, you can design products that can literally generate cold or heat on demand. And get this, without any batteries or plugging anything in. And this is where the science gets super practical. You know those instant cold packs for sports injuries? That's just a controlled endothermic reaction sealed up in a bag. You snap it, something inside dissolves, and it just starts sucking heat from its surroundings, making the pack ice cold. And those instant hot packs for your hands in the winter?
It's the exact same principle, just flipped. It's using an exothermic reaction that's designed to release heat.
So, the next time you feel that sudden chill or a surprising bit of warmth from some everyday object, you'll know exactly what's going on. It's just a cool reminder that our world is full of these tiny invisible energy exchanges happening all the time. Makes you wonder, right? What other examples are out there? Once you start looking, you'll see the answer is, well, it's everywhere.